Hey guys, in today's video, we'll cover the question increasing triplet subsequence. This is a commonly asked question in interviews of Google, Amazon, and Facebook. It's a medium difficulty problem, so let's jump right into it. The question is, given an integer of array nums, return true if there exists a triple of indices I, j, k, such that I less than j less than k, and number at I less than number at j less than number at k. If no such indices exist, return false. This basically means that if in your array there are three numbers in an increasing order, you'll just return true, otherwise just return false. Let's look at some examples and edge cases here. Here we're given three arrays. If you look at the first one, I can tell that 2, 3, and 5 are in the increasing order, so this is true. In the second one, I can find the increasing triple subsequence. I see that there is 3 and 4, but there isn't a third number there, which will make it true. So we'll mark this false. The third one is a little interesting. I see that the increasing subsequence here is 1, 5, and 6. Notice that these numbers aren't continuous like number 1, but there is a valid solution. Your increasing numbers don't have to be continuous. They just have to be in ascending order. Keep this in mind when you're working on the solution. So let's look at how we'll solve this. This is a good stopping point if you want to practice solving this on your own. Okay, to solve this, we'll just traverse through our array or vector in this case. Now at every number, we want to check if there has been two numbers before that one, which were less than in value. To keep track of this, we'll need to define two integer variables. And so while looping, if we find any numbers less than these variables, we'll just replace them. This is an important step and our algorithm wouldn't function without it. So we'll first check if our number is less than or equal to A. Then we'll check if it's less than or equal to B. We need to keep it in this order to maintain ascending increasing order. For it to be less than or equal to A or B, our number has to be the maximum integer possible when we actually defined it in the beginning. So we'll define our variables to max int when they start. If it's neither less than A nor B, that means there is an increasing triple subsequence and we just return true. In our loop, if it never hits true, we'll just return false at the end of it. Let's look at the complexity of this code. We are looping through once, so our runtime complexity is O of n. For our space complexity, we are just using two variables to store data for our algorithm to function, which is a constant number and will remain constant as our algorithm scales. So the space complexity for this would be just O of 1.